For 60 years, astronomers have looked for extraterrestrial civilizations and planetary systems without success. The author of a research published in the International Journal of Astrobiology suggests that the search for alien intelligence may have a greater probability of success if it is combined with the search for extraterrestrial civilizations that are migrating. For instance, alien civilizations may abandon their native planetary systems if they are threatened with extinction. Riding planets that are free to drift is one way to accomplish this. For very huge populations setting out on interstellar travel, free-floating planets can provide space, resources, and radiation protection. Huge starships, often known as planet ships, are most likely technologically unable to do the same. Extraterrestrial civilizations may be able to emit less and less apparent technosignatures as their technology develops, especially if they are contentedly located in a relatively stable habitable zone of medium and low-mass main-sequence stars. If advanced extraterrestrial civilizations often exhibit this trait, it may be difficult to find their technological traces in the habitable regions of main-sequence stars. However, at times of adversity like destructive cosmic occurrences and tragedies brought on by civilizations, advanced extraterrestrial civilizations would have to engage in activities yielding observable technosignatures. Large populations of extraterrestrial civilizations might relocate inside their native planetary systems or to other stars in order to escape existential threats. They would leave behind recognizable technosignatures after migrating to and colonizing other cosmological realms. Extraterrestrial civilizations would move away from their host stars, becoming red giants, and toward the habitable zone in their planetary systems, increasing their orbital distances. They would leave behind observable technosignatures as a result of their migration and colonization of more distant planets and moons in their home planetary systems, such as atmospheric technosignatures, infrared excess technosignatures, and communication technosignatures. Some highly developed civilizations may build stellar engines, some highly developed civilizations may exploit free-floating planets as interstellar transports, and some highly developed civilizations may send their populations or technologies to other stars during flyby events. Advanced extraterrestrial civilizations may spread throughout the galaxy using a variety of interstellar migration and colonization techniques, each of which can leave behind a distinct set of visible technosignatures. Free-floating planets may make it possible for extraterrestrial civilizations and technologies to travel across the galaxy and arrive in planetary systems. When alien civilizations use free-floating planets to travel to, investigate, and inhabit planetary systems, their biological species, post-biological species, or their technologies turn into cosmic hitchhikers. Free-floating planets can offer a stable surface gravity, a lot of room, and resources. Free-floating planets with surface and deep oceans can offer water as a consumable resource and as radiation protection. They could be used by extraterrestrials for a variety of purposes, such as sending huge numbers of post-biological species to explore other worlds or dispersing populations of their own species over numerous planetary systems to maintain the continuity of their civilization. In order to examine stars, planetary systems, and the interstellar medium, extraterrestrial civilizations may also send cosmic hitchhikers in the form of intelligent devices, probes, and other technology. Free-floating planets that are passing by their parent planetary systems may be visited by cosmic hitchhikers. The quantity and distribution of free-floating planets in the galaxy, which in turn depends on their origin, would determine the frequency of flybys of these planets. According to one theory, star clusters should be the place where many free-floating planets should have their beginnings and homes. However, it was found through computer simulations of the Orion Trapezium star cluster that around 80% of its free-floating planets would immediately leave the cluster once they were released from their host stars. Oort-cloud objects can be ejected from their systems by stars with up to 7 times Sun mass or by a supernova with up to 20 times solar mass. This causes the Oort-cloud objects to break free from their host stars. In order to create artificial free-floating planets, cosmic hitchhikers may colonize cosmic objects that are native to the outermost parts of their planetary systems and use technology to eject the things from their planetary systems. These things might resemble SETNA. SETNA is an object outside the Kuiper belt with a very eccentric orbit. Similar objects to SETNA may have very eccentric orbits that would transport them 60 to 70 astronomical units from their host stars to the inner border of their Oort clouds. Advanced civilizations that have already explored their planetary systems to distances of at least 60 astronomical units from their home stars would be those that are capable of achieving this. Planets located at a distance less than 40 astronomical units from their host star require a lot more energy to adjust their motion than SETNA-type objects located at a distance of more than 500 astronomical units. Earth's kinetic energy would need to be changed by around 10 to the 33rd joules in order to adjust the orbital speed to the speed required to escape the Sun's gravity. Changing an object's orbital speed to the escape speed would result in a change in its kinetic energy of about 10 to the 26th joules for an object with a mass similar to SETNA's, which is 10 to the 21st kilogram and located in the inner Oort cloud at a distance of 2,000 astronomical units. This is a massive quantity of energy. But we can put things in context. Oort-cloud objects could be transformed into free-floating planets by a civilization that has advanced propulsion technology and gravity-assist events. This civilization may be several hundred years or millennia ahead of us in technical development. The propulsion systems may direct the SETNA-type object toward a star of their choosing once it has been transformed into a free-floating planet. It might be a distant star, measured in light years. Perhaps it's a flyby star. Some migrating civilizations might have the technology to modify the motion of their free-floating planet to enter an orbit around a different star in the far reaches of their planetary system. After transforming their free-floating planet into a bound planet in the planetary system of another star, they may later travel there to populate planets in that system. What is the prevalence of planets that float freely? The greatest known collection of rogue planets, numbering at least 70 and maybe as many as 170, was found in December 2021. They have ages of between 3 and 10 million years, masses between 4 and 13 Jupiter mass, and are found in the OB association between Upper Scorpius and Ophiuchus. It is most likely that they formed either by the gravitational collapse of gas clouds or by the formation in a protoplanetary disk followed by ejection as a result of dynamical instabilities. Technosignatures formed on free-floating planets may be wrongly thought to originate in planetary systems, clusters of stars, galaxies, or empty areas of space since they are not easily detectable. This might happen if, at the time of the observations, a free-floating planet was situated near a planetary system, cluster of stars, galaxy, or expanse of empty space. The free-floating planet may shift away from the line of observations in the future, making it impossible to detect the technosignatures along that line. Therefore, it is advised to look for free-floating planets in areas where anomalous cosmic occurrences or inexplicable electromagnetic radiation emissions are found. Spacecraft can be maneuvered, accelerated, or decelerated using magnetic sails. The prospect of finding extraterrestrial civilizations by looking for the spectral signature of their interstellar travel was investigated by scientists. They came to the conclusion that the low-frequency radio emissions of cyclotron radiation produced by the interaction of the interstellar medium with a magnetic sail would be the most observable form of radiation. On free-floating planets, technological activity by extraterrestrial visitors may result in electromagnetic radiation emissions that can act as technosignatures. On the planets that are free-floating, for instance, waste heat from their technology may emit electromagnetic radiation with mid-infrared wavelengths. Therefore, anomalous infrared emissions coming from free-floating planets with cold surfaces could be technosignatures of interstellar travelers. Infrared excess is one example of an uncommon aspect of such emissions. Other examples include remarkable fluctuations in the intensity of the emissions and relatively large amounts of the emissions. It's possible that technological artifacts in planetary systems could be proof of the existence of alien species or technologies on free-floating planets. There have been several theories about extraterrestrial artifacts that might be present in the solar system. Inactive extraterrestrial technology that is still present on planets, the Moon, or in the interplanetary space of our solar system is one of them, as is speculative extraterrestrial technology that is still in the solar system and secretly surveying humanity. Imagine robotic snooping probes, sometimes known as lurkers, were found in the solar system. They might be examined and records with transmission timestamps retrieved by manned or automated missions. The apparent journey of the receiver of transmissions and its current apparent location can be predicted by analyzing the timestamps, locations of the lurkers for those timestamps, and transmission directions. To determine if the broadcasts were transmitted to recipients on the free-floating planet, a search for one may be made. A series of fictitious circumstances would be required for this extremely unlikely scenario to come true. But it might only be one of several resources that could help the search for extraterrestrial intelligence. If a free-floating planet carrying extraterrestrial species or their technologies were gravitationally captured by a planetary system with the aid of extraterrestrial technologies, the captured free-floating planet would retain the extraterrestrial species or their technologies. As a result, captured free-floating planets with wide-orbit planets in the periphery of planetary systems may contain extraterrestrial artifacts. Probes should be dispatched to study wide-orbit planets and potentially captured free-floating planets in the Oort-cloud of the solar system or in the Oort-clouds of neighboring planetary systems in order to look for extraterrestrial artifacts. The possibility that free-floating planets inhabited by intelligent extraterrestrial life have traveled in our solar neighborhood over the past few billions of years is quite remote. Moving intelligent biological species or post-biological organisms with artificial intelligence may currently be traveling on free-floating planets hundreds of light years or less from Earth in search of a new home. It is advised by scientists that our quest for intelligent life in the universe should include looking for such space tourists.